Welcome to Grab and Go Info. Statistical concepts are commonly asked in data science and machine learning interviews. In this tutorial, we'll delve into the top 12 interview questions related to these concepts and provide guidance on how to effectively answer them. The Python code for simulating the statistical concepts will also be provided where is applicable. The link for the code is in the video description. Let's get started. Question 1. What is the central limit theorem? The central limit theorem states that the sampling distribution of the mean of a large number of independent, identically distributed random samples will approach a normal distribution, regardless of the original population's distribution. Here's a sample Python code to demonstrate the central limit theorem using the NumPy and Matplotlib libraries. This code creates a non-normal population, takes multiple samples from the population, calculates the means of these samples, and then plots the distribution of the sample means, illustrating the central limit theorem in action. Question 2. What is the law of large numbers? The law of large numbers states that as the number of trials or observations in a random experiment increases, the sample average converges to the expected value, or true population mean. Here's a sample Python code to demonstrate the law of large numbers using the NumPy and Matplotlib libraries. This code creates a normal population, takes multiple samples from the population with different numbers of trials, calculates the sample averages, and then plots the sample averages versus the number of trials, illustrating the law of large numbers. Question 3. What is a p-value? P-value measures the probability of obtaining results that are at least as extreme as the observed results if the null hypothesis is true. P-value ranges from 0 to 1. A high p-value means that there is a high chance of obtaining the results as extreme as observed if the null hypothesis is true, so we fail to reject the null hypothesis. A low p-value means that there is a low chance of obtaining the results as extreme as observed if the null hypothesis is true, so we reject the null hypothesis. The typical threshold for p-value is 0.05, meaning that if the probability of obtaining the results as extreme as observed given the true null hypothesis is less than 0.05, we reject the null hypothesis. Here's a sample Python code to calculate the p-value using a one-sample t-test with the SciPy library. This code tests the hypothesis that the sample mean is equal to a given value, using a significance level of 0.05. This code uses the t-test oneSamp function from the SciPy library to perform a one-sample t-test on the given sample data and calculate the p-value. It then compares the p-value with the significance level to determine whether to reject or fail to reject the null hypothesis. Question 4. What is the standard deviation? The standard deviation provides a measure of the spread or variability of the data around the mean. A smaller standard deviation indicates that the data points are clustered closely around the mean, while a larger standard deviation indicates that the data points are more spread out from the mean. The formula for calculating the standard deviation of a population is standard deviation equals the square root of the sum squares of xi minus mu divided by n. The formula for calculating the standard deviation of a sample is standard deviation equals the square root of the sum squares of xi minus mean divided by n minus 1. N minus 1 is used for sample standard deviation because using n underestimates the standard deviation. Here's a simple Python code to calculate the standard deviation of a dataset using the NumPy library. In this code, we use the std function from the NumPy library to calculate the standard deviation of the given dataset. The DDoF parameter is set to 1 to compute the sample standard deviation. DDoF is delta degrees of freedom for population standard deviation. Question 5. What is a confidence interval? Confidence interval is used when we would like to know a population parameter, but only have access to samples. Since the true population value is unknown, we do not know if the sample value is greater than, less than, or equal to the population parameter. A 95% confidence interval can be interpreted as, we are 95% confident that the true population parameter is within confidence interval lower bound and upper bound. If we repeat the sampling 100 times, 95 times out 100 the true population value is within the confidence interval. Suppose we want to determine the mean height of all adults in the United States. We can take multiple samples from the adult population, compute the sample mean, and construct a confidence interval. A 95% confidence interval indicates that if we were to repeat this process 100 times, we would expect the true average height of the U.S. adult population to fall within the interval 95 out of 100 times. What affects the size of the confidence interval? 1. Variation. A population with low variation leads to samples with low variation and a narrower confidence interval. 2. Sample size. As the sample size increases, the confidence interval becomes smaller, assuming other factors remain constant. How to calculate the confidence interval? 1. Confidence interval for population mean. When the population standard deviation is known, confidence interval equals x bar plus minus c times sigma divided by the square root of n, where x bar is the sample mean, sigma is the population standard deviation. N is the sample size. Z is the z-score associated with the desired level of confidence. 2. Confidence interval for population mean. When the population standard deviation is unknown. Confidence interval equals x bar plus minus t times s divided by the square root of n, where x bar is the sample mean, s is the sample standard deviation, n is the sample size, t is the t-score associated with the desired level of confidence and degrees of freedom. 3. Confidence interval for population proportion. Confidence interval equals p hat plus minus c times the square root of p hat times 1 minus p hat divided by n, where p hat is the sample proportion, n is the sample size, and z is the z-score associated with the desired level of confidence. Here's a sample Python code to calculate the confidence interval for a given sample using the t-distribution from the SciPy library. This code calculates the sample mean, standard error, degrees of freedom, and t-distribution critical value. It then computes the confidence interval for the given sample data using the calculated values. Question 6. What are type 1 and type 2 errors? Type 1 error is the same as the significance level or false positive rate. It is when the null hypothesis is rejected when it is true. Type 2 error is the same as false negative rate. It is when the null hypothesis is not rejected when it is false. The values of type 2 error equals 1 minus power in hypothesis testing. Power is the probability of detecting the difference if it exists. It represents how confident we are about rejecting the null hypothesis. Question 7. What's the difference between a covariance and a correlation? Covariance measures the degree to which two variables change together, indicating the direction of the relationship. A positive covariance means that as one variable increases, the other tends to increase as well, while a negative covariance indicates that as one variable increases, the other tends to decrease. However, covariance does not provide information about the strength of the relationship, and its value depends on the scale of the variables, making it difficult to compare covariances between different datasets. Correlation is a standardized version of covariance that measures both the direction and strength of the linear relationship between two variables. The correlation coefficient ranges from -1 to 1. A value of -1 indicates a perfect negative linear relationship, 1 indicates a perfect positive linear relationship, and 0 indicates no linear relationship. Since correlation is unitless and standardized, it allows for easy comparison between different datasets and variables. Question 8. What's the difference between a z-test and a t-test? Z-test is used when the population standard deviation is known, and the sample size is large. The z-test assumes that the underlying population is normally distributed, or the sample size is large enough for the central limit theorem to hold. In a z-test, the test statistic follows the standard normal distribution, which has a mean of 0 and a standard deviation of 1. T-test is used when the population standard deviation is unknown, and the sample size is small. The t-test assumes that the sample is drawn from a population with a normal distribution. In a t-test, the test statistic follows a t-distribution, which is similar to the standard normal distribution, but has thicker tails. The t-distribution is characterized by the degrees of freedom, which depend on the sample size. As the sample size increases, the t-distribution approaches the standard normal distribution. Question 9. What is the expected value of a binomial distribution? A binomial distribution is a discrete probability distribution that models the number of successes in a fixed number of independent Bernoulli trials, each with the same probability of success. It is used to describe situations where there are only two possible outcomes in each trial, often referred to as success and failure. The probability mass function of a binomial distribution is given by this equation, where px equals k is the probability of observing exactly k successes in n trials. N is the total number of trials. K is the number of successes, where k is greater than or equal to 0 and less than or equal to n. P is the probability of success in each trial. P is greater than or equal to 0 and less than or equal to 1. Cnk represents the binomial coefficient, which can be calculated as n factorial divided by the product of k factorial and n minus k factorial. The expected value of a binomial distribution is given by the product of the number of trials and the probability of success in each trial. Mathematically, it is represented as expected value equals to n times p. Question 10. What's the impact of removing the data below the mean of a normally distributed dataset? 1. Inflated type 1 error rate. Removing values below the mean or any other threshold alters the distribution's characteristics and may violate the assumptions of the statistical test being used. If the test is not robust to these changes, the type 1 error rate could be inflated. 2. Non-normality. If the original sampling distribution was approximately normal, removing values below the mean will lead to a non-normal distribution, which might not be suitable for parametric tests like t-tests or z-tests that rely on the normality assumption. 3. Reduced sample size. Filtering out values will reduce the sample size, which can decrease the statistical power of the test. This means you might be more likely to commit a type 2 error while potentially increasing the type 1 error rate. 4. Bias parameter estimates. By removing values below the mean, you introduce bias into the sample mean and variance estimates, which can affect the test statistic and p-value calculations, leading to incorrect conclusions about the null hypothesis. 5. Change in effect size. If the goal is to estimate the effect size or the magnitude of a relationship between variables, removing values below the mean will likely change the estimated effect size and might lead to erroneous conclusions. Question 11. What is the standard error of the mean? The standard error quantifies the precision of a sample statistic as an estimate of the population parameter. The standard error is calculated as standard error equals sigma divided by the square root of n, where sigma is the population standard deviation, and n is the sample size. In practice, the population standard deviation is often unknown, and the sample standard deviation s is used as an approximation. Standard error equals s divided by the square root of n. A smaller standard error indicates that the sample statistic is a more precise estimate of the population parameter, while a larger standard error suggests more variability between samples. The standard error is used in various statistical tests, such as hypothesis testing and confidence interval calculations, to assess the reliability of the sample estimates and make inferences about the population. Question 12. What is the margin of error? The margin of error represents the range within which the true population value is likely to fall, given the observed sample statistic and a specified level of confidence. The margin of error is typically calculated as the product of the critical value and the standard error of the sample statistic. Critical value is from a chosen probability distribution, such as the z-distribution for large samples or the t-distribution for small samples. For a sample mean, the margin of error can be calculated as margin of error equals critical value times standard error, where the critical value depends on the desired level of confidence, for example, 1.96 for a 95% confidence level in the case of a z-distribution. If you have made it this far, you probably find the information in this tutorial helpful. Please click the like button and subscribe to the channel to get notified when I publish new videos like this. To learn more about data science interviews, please click the YouTube playlist on the screen now. Thank you for watching and see you in the next video.